Hello, everyone. My name is Aaron Dennis, and this is my workshop video number 2 for CSC-381. And in this video, like the first one, I'll be covering Dead by Daylight. And just to give you a quick recap of that game, it starts out with 4 survivors against 1 killer. And the objective for the survivors is to escape through the exit gate. In order to do that, they'll need to power up turn on the power by repairing generators across the map. And this entire PDA diagram will be from the perspective of the survivors. So just keep that in mind as we walk through it. But anyways, moving on here. Here was my original DFA diagram. I don't have time to go through each step, but if you would like to see that, go and check out workshop video number 1 on my channel. But anyways, the thing I would like to pull from this, I hope you can see it, is that if the survivor is chased and caught by the killer, they move to the dead state. But I had it here where they could get revived by a teammate, which is correct, but there's really nothing here that prevents this from happening over and over again. Like, this could kind of be repeated infinitely many times of getting chased, getting caught, reviving, chased, caught, reviving, and just like over and over. In the real game, that isn't allowed. What actually happens is once you're caught by the killer, you're placed on a hook. And once you get placed on the hook for the 3rd time, you're permanently dead. And so that's kind of how it actually works. So that was kind of a limitation of this. And so I drew up another DFA. And as you can see, each one here, it's sort of like the same shape as that triangle shape. But instead of being it all in one here, it's got 3 different iterations. So each time they get hooked with this H input signal here, they sort of move on down the line. And then once they get hooked for a 3rd time, they've moved this permanently dead state. And this DFA diagram works really good. It does exactly what we need it to do. However, it's not really efficient. There's 15 states, and there's sort of some repetition there. So with 3 different things kind of all trying to do the same thing. So we'll just look to optimize that with the PDA. And I'll show you guys my JFlap diagram here. I'll walk through this one. Basically, instead of starting out in a lurk state, we're going to start out down here. And these states down here are kind of just like placeholder states. So as you can see what's going on here, we're just going to be putting these characters. I chose X. It could be any character, but we're going to be putting 3 X's onto the stack to represent the fact that we start out with 3 lives. And then just the same as before, we can sort of complete tasks, whether it be fixing a generator, sort of playing cat and mouse with the killer, or a combination of those things. And then at some point, we might get caught by the killer. And if that's the case, we get placed on the hook. An X is popped off of the stack, and then we have to move to this hook state. Once we get here, the program is going to look and see is the stack empty? Because if the stack's empty, that means we're out of those 3 lives, and it's going to push us into the permanently dead state. In this case, it was the first time that an X was popped off. We would still have 2 lives remaining, and we could just wait here until we get revived by our teammate, go back to completing tasks, and then the process would repeat until eventually we do run out of lives, or alternatively until the power comes on. And to show you a little bit more detail about this, I guess let's use some test input strings and watch what happens as the PDA handles it. Starting out here, you can see we have this is the stack, and it's just the Z character. What that means is we're at the bottom of the stack, so we don't really need to worry about that yet. What's going to happen is we're going to start out, before we even start reading any input at all, we're going to push 3 X's onto the stack. At this point, we can start completing tasks. We're going to repair those generators, and eventually we get over here to where we're evading the killer, and we get caught. So you can see right here we have 3 X's, and then now we take another step. You can see we lost the life there. We wait here. We're not alive yet, so we wait here until we get revived by a teammate. Go back to completing tasks, and In this case, as we were completing one of our tasks, the power came on, and this was an example. This was an example of basically the survivors winning the game, and this is an acceptable string because it ended with the power coming on there. Let's try out one more just to get a different, to make sure that this whole thing works down here with the when we run out of lives, putting us in that other except state. And start out here, we're going to do the same thing as before. Start out with 3 lives onto the stack, 3 X's onto the stack representing 3 lives, and completing tasks. This time, before we even had a chance to fix the generator, we started getting chased by the killer, and they caught us, so we lost a life. But luckily, we're not out of lives yet, and we did get revived. We go back to completing tasks. Continuing on, we got caught by the killer again. Same thing, completing tasks. And this time, when we got caught by the killer and hooked, you can see the only thing that's left on the stack is a Z. That means we're out of lives. We're at the bottom of the stack. So it's going to move us over to that dead state, which is another final except state. And this string is acceptable as well. And this would be representative of the killer winning the game. So that kind of covers the PDA diagram. And you can take one more look at it here. As you can see, there's 9 total states, including these 3 placeholder states. And one second here. Basically, what that means is we had 15 before, down to 9. That's a 40% reduction in the number of states. It could even be better than that because, like I said, we had those 3 kind of placeholder states. So really, it was like 6 states that we were using a majority of the time. But we'll just go with 40% for now. Pretty good reduction. And here was the alphabet that I used. Again, pretty self-explanatory. The only thing I would like to point out is I considered splitting up and having some more characters for completing tasks, like maybe R for reviving your teammate and G for generator repaired or V for evaded the killer. But when I really thought about it, all of those transitions that I just mentioned are the exact same because we're just moving to the lurking state and we're not pushing or popping anything from the stack. So by doing it this way, it kind of keeps the whole thing a little bit cleaner and we don't really lose out on any functionality. And I'll prove that a little bit later when we go over the C++ code. But anyways, here's the language. Again, it's kind of confusing at first glance. One thing to look really quick at here, I used an exponent to the 3rd power, but basically what that means is just it's the same thing as it's just this inside part here repeated 3 times, as you can see down there. And then breaking apart each individual piece of it. First, this is kind of like that upper area of the triangle where we're just completing the tasks. We can either fix a generator, evade the killer, or a combination, and then the whole process can sort of repeat 0 or more times. Then at some point, we might get hooked by the killer, and you can see, and then get revived. And that could happen, really it could happen 0 or 1 times. And then the power could come on 0 or 1 times. And then that whole process is going to repeat, like, as I said before, like 3 sort of iterations of that. And I know it's still maybe a little bit confusing to some of you, but I promise this is like represents what's in the PDA diagram on JFlap. And if you have any further questions, please just let me know. And that brings us, I guess, to the implementation in C++. So we'll take a look at the code there. I think it's most useful if we start out looking at the player class that I made here. So each, basically each input here is, or each member function is representative of the input. And I'm sorry that the numbers don't really match up there, or the letters, but you can see they do here really clearly. So P is going to stand for power on. We get an E from the alphabet, that's going to be evade or killer chasing. F is going to be fix or repair. H is going to be hooked or caught. It's going to call that function. And then finally C is going to call the completed function. And so, and then we also have variables to track the current state and the player's number of lives. And then, yeah, basically our main function here is going to take an input string. It's going to print out a welcome message and then take an input string. And then it will read through that string character by character. If it recognizes one of these characters, it will call the function associated with it. And then if it doesn't recognize the character, it's going to just print out an error message there. So that kind of enforces the string being, I guess, acceptable. And then looking inside those actual functions that are called over here, our first one is just going to be when we declare a player object. We're going to get those lives added on, and we're going to print out the number of lives there. It'll always be 3 at the start here. And then it'll tell us we're in the lurking state to start out. And then we have these kind of we have the function to return the current state. And then all these ones down here are basically each input, what is sort of like, depending on what your current state is, that's going to sort of print out a message and then move you into that next state. So if the, for instance, if the power comes on, we're going to print out the power message and, you know, that we're escaping. And then if we get a evade or E for evade, then that will mean we'll get the killer chasing function here, and it'll print out that appropriate message. Same for the F or the repairing signal, input signal. And then this is where it gets a little bit more interesting. If you get a H or hooked input signal and you get, it'll call this caught function. And what that will do is it'll tell you that you were caught by the killer, and then it'll take one of your lives away, and then it will look, okay, are you out of lives, basically? And if you are, then it'll tell you the game's over. If not, it'll tell you how many lives you do have left, and then it'll, again, print out sort of a status message and move the state. And then finally, the last one here is the same thing. And this is what I was sort of mentioning earlier. Again, we don't need separate variables to track, like, or separate characters in the alphabet to say specifically what task was completed, because if we keep track of the current state and then we have that same, just that C character from the alphabet, that will tell us exactly, that will be able to print out the appropriate message for what's actually happening in the game. For instance, you know, if you were hooked and then it was completed, that would print out this message that you were rescued. Or if you were fixing and you completed it, that would print out the generator's been repaired, and so on. So with that being said, I would just like to real quick test out the same input strings as before with the C++ code instead of JClap this time. So here we go. Got our input string, and with this one, same as before, kinda. Right away from the start, it's going to print out the welcome message, tell us we have 3 lives and that we start in the lurking state, completing tasks. Eventually, we get caught and we have 2 lives left, it tells us, and we get on the hook, but we get revived. Continue completing our tasks, and this was the one that the power was restored and we made it out. We escaped, the survivors won. Alternatively, we could have the other one. We'll test that out finally. Here we go, sorry. Grab this input string, copy it over. And same thing here, except this time it's gonna be the one where the killer wins. So again, yep, we start out with 3 lives and we start out in the lurking state. We get caught, we get revived, complete the task. This time here, same thing. And then finally at the very end, right here, run away and try to hide the killers after you. We get caught, and then it tells us we're out of lives and we did not escape. So again, same thing happened there. I apologize, I'm kind of running short on time here, but yeah, that's pretty much it for my presentation. I'm really proud of how everything turned out. If you do have any more questions, let me know, and thank you so much for watching, guys. Bye.